You know, you can't talk about pressure stuff without a vacuum pump. The other day I was packing to come out here, and two of my colleagues both needed the vacuum pump on the same day. I need the vacuum pump, it's packed. Oh, now I need the vacuum pump, it's packed. We didn't care, we got it out. All right, so I've got a vacuum pump under the table. I don't have to pull that out for you to take a look at it. And let's turn on a little thermometer here. What's the first thing you ever used a vacuum pump for? A balloon. What else? Cool. Boil water, reduce pressure. Okay. Say again. Excellent. Okay. All different things you use your vacuum pump for. Let's see if I have some luck here. Maybe. We'll move the pump plate a little closer. What I have up here, if I can keep you guys from getting sick again. I don't get to use a flex cam as much in my classroom anymore. Can you see the temperature on that? All right, hold on. I can't see anything anymore. What does it say? 21.0? That's nice. Okay, so what I have in here, and I'm going to move down just a hair. Okay, got some alcohol in there. Works a little faster than water to show boiling at reduced pressure. So there we got that. Ethanol, ethyl alcohol. And I put a couple little boiling stones in there. And we'll turn on the vacuum pump. I can show you what kind of pump it is here in a minute or after. So I picked ethanol because it works, obviously alcohol has a much lower boiling point than water. And if you put a couple little boiling stones in there, oh, it's boiling like crazy all over the place. That's nice. So you can show alcohol boiling. This is a good enough pump that you can do water, which is great. Now, let's check out the thermometer. Can you see it? You cannot. Let's rotate this and see if we get any light on it. Oh, of course not. At all? Somebody can see it. 16? Okay. You put stuff in a pump and you reduce the pressure to show the kids that at reduced pressure, things will boil easier. Of course, that's great. Do you ever put a thermometer in it? Oh my God. You put a thermometer in it and the kids go, okay, yeah, it's going to boil. And then you go, uh-huh. What's the temperature doing? And they're like, it's going up. Really? They're like, okay, so I'm going to keep boiling this. What's the temperature doing? And they look at you, and then they look at each other. It's more fun the higher the kids are academic level, because they're like, okay, that's great. We're boiling it, and it's getting colder. And the longer we boil it, the colder it gets. And then you say, that makes sense, right? You boil things to cool them down. You boil things to cool them down. Yeah, that's right. And the kids are like, what? What? And you got a couple of them going, oh. And the rest of them are going, getting really kind of upset at you. And you're like, okay, it's boiling, boiling. Can you guys see what the temperature is in there? No, not at all. Here, I'll turn it off. Still boiling. Carefully let the air back in. Careful. What is it at? 9.3. It is so cold. I mean, it's like cold, cold, cold. And you start seeing condensation on the outside. So immediately, what do you think you could do with this? Music. chill a martini by boiling it. In my next life, I'll have a bar. There'll be these all on the front table. And I could charge $24 a piece for them. Oh, yeah. It will absolutely boil. And yes, I have actually chilled a martini with a vacuum pump. It's true, it doesn't water it down. So James Bond had it all wrong. Shaken, stirred, or boiled? Boiled, you know. There it goes, the boiling martini. Don't anybody steal my second job, the bar. So that just cracks me up. Okay, now, then that brings up an interesting idea. Could we boil, you know, if I'd been thinking, that wouldn't be denatured ethanol. But my thought is, could you actually boil alcohol till it freezes? And the answer is, yes, you can, but not with this pump. So I thought, all right, first of all, why can you boil it? Clearly, the molecules that are moving fast enough that the pump can take them out as a gas will leave the molecules that are not moving as quick in the liquid. And so then those guys get just enough energy, they evaporate, and you pull those out, and you pull those out, you pull out the fast-moving ones, and then back behind, you know, there's something that's not moving as fast. I think we can all think of examples. Come on, we all teach. Okay, we can all think of examples, all right? But my thought was, okay, could we actually boil something till it froze? And the answer is yes, but what you have to do is find something where the triple point is just at about the right. You don't have to cool anything too much. You maybe want to drop it 10 degrees. And so I thought, all right, what's something that has a triple point where you only need to drop some, well, lordy, it's just liquid nitrogen. Something that has a really small range that it's a liquid. And so I thought, let's try some nitrogen. So I'm going to put on this glove in an attempt to be safe. But I'm afraid I'm not going to be able to pick up that cup. So I went hunting for a triple point diagram for nitrogen. And turns out they're kind of hard to find. Had to get a hold of NIST, had to get a hold of a whole bunch of different people. And I ended up, Paul Smith at Purdue ended up helping me find one. Okay, that's boiled down just enough in a styrofoam cup. So I'm going to put the little nitrogen right on there. Well, that's kind of cute. It's very cute. Okay. Lovely. Now, move this into position. I want to shoot down through the top of that. All right, Jason, can we try this? Just about. You know what? It's going to be easier to move the pump plate back just a little bit. Okay, now that's a styrofoam cup that's painted blue inside with spray paint that won't dissolve the styrofoam. Okay, you'll see why here in a minute. You can see the nitrogen boiling off and a little water vapor in there. All right, so the thought was if we could find something where the triple point was only about 10 degrees where something would stay a liquid, what would happen if we shoved that in a vacuum pump? So, nitrogen does. Okay, now seriously, folks. Can you boil nitrogen till it freezes? That just sounds impossible. Oh, there it's boiling big time. You're watching nitrogen boil. Excitement of your morning. Okay, but think about what it's doing. It's getting colder. and the pressure's going down. So you're creeping along this liquid-solid line. And the fast ones are going out. You only got to drop the temperature maybe 10 degrees. Come on, buddy. Come on. Come on. We're still going. Come on, little pump. There we go. I was a little generous with the nitrogen. Usually it takes 54 seconds and that song is 52. So look at that, solid nitrogen. Oh, it's so awesome. You're like, oh, that's so awesome. If you look in your handout, there's a table. There's the triple point diagram, and then there's a table in there. And so it's like, all right, if I put the pressure back in, the melting point of nitrogen is so close as well. Look, it's a nitrogen snow cone. From the side, it's like crawling out. Of course, what do the kids want to know? Can you eat it? Okay, so let's see. You know what, I'm going to leave that out there. Okay, now, something that maybe you haven't seen a whole lot of, you are now watching nitrogen melt. That seems like an oddity, doesn't it? What's the white cloud in there? Yeah, carbon dioxide. So you've got liquid nitrogen with a liquid CO2 on top of it, and then some CO2 cloud. So it's like, you know, maybe the surface of Venus or something. Oh, that's so cool. All right. And sometimes we can actually get the nitrogen out of there. That nitrogen is too cold to boil. Look at it. Oh my God. It's a mixture of liquid gases. Check that out. Should we just let it sit here and do its thing? Or should we clean it all up by tossing it? Isn't that just awesome? Can you do it again? Yes, you can. You boil it again, and it will refreeze. So first time I did that, I literally went screaming down the hall, oh my God, oh my God, oh my God. And they were like, oh, she's lost it.